Hey there, pre-calc friends. Shinner's back here. We are going to continue our learning of conic sections here, and we are going to be talking about hyperbolas today. So before I jump in, I do just want to remind you of what a hyperbola looks like, so you can kind of see, we've been referring back to these shapes, so you can kind of see how the hyperbola is going to have two different branches. And this would be an example of like a vertical hyperbola where the branches are vertically on top of each other. But we also could have horizontal hyperbolas as well. So that is what we're going to be focusing on this week. And the cool thing is the definition and actually the equation is very similar to the ellipse. The only difference here is instead of adding the distances from the foci, we're just subtracting them. So that's the only difference. So locus of points, so the collection of points x, y, whose difference, so I'm subtracting the two distances, whose difference of the distances to 2 points. Remember those points we call the foci, those kind of special points that aren't really points on the graph, but they help us build the graph. So it just equals some constant. Okay, so now we are subtracting two distances to get to some constant, okay? So like I said, we can have hyperbolas that are vertical, right? That you could have like this and this. Oops, not very good. We could have more of a horizontal hyperbola where the branches are horizontal. And we are going to still refer to the center here as HK. So that's still HK. We are still going to call these major vertices, and the distance between the center and my major vertice is still going to be A. Okay, so this to this is still going to be A. B is going to be, see what I did there? A little bit weird. We're still going to call it a minor vertice, but notice it's actually not a point on my graph whatsoever, okay? So actually what that B is going to do for us is it's going to give us the slope of the asymptote that helps me build my hyperbola. All right, so hold tight on that. We'll jump into that during the examples. But just so you know, if you're like, why do we have this random letter B out in left field here? Missioners, why are you making us graph that? It will help us build our asymptotes, which are going to help us build our hyperbolas. So hold tight on that. We also still have foci. Now, these foci are going to be kind of inside the branches here. I kind of think of the branches as kind of like little cereal bowls or something. The foci are the cereal. And the distance from the center to the foci is still going to be called letter C. So foci to the center is still letter C, okay? So you might be asking yourselves, well, what's the equation of a hyperbola? And it's going to be very similar to the ellipse. I'm actually going to start with the horizontal one. So still x minus h squared all over, right? The horizontal there would be a squared. The only difference is instead of adding, I'm going to subtract, okay? Which makes sense because we said we are subtracting the distances instead of adding them. So it kind of connects here that I would have a subtraction in my equation. We are still going to have that set equal to 1, all right? So a horizontal hyperbola is when the x branch or the x here comes first. So in the vertical hyperbola, this y is going to come first, okay? So that's how you know if it's going to be a horizontal or vertical hyperbola, whichever variable comes first. Is it y minus k or is it x minus h? Okay, so you just kind of swap those. The A value is always with the major vertice though, okay? So don't worry too much about what's A, what's B. Just remember, if it's under that first piece, that's going to be a major vertice, okay? And we'll do examples in a second. I hate when I get too theoretical with all these equations and I'm like picturing you in your homes like, what is she talking about? But once I do some examples, I think things will click together. Last thing I want to touch on here, guys, is, we always have that equation to get us to our foci. For ellipses, it was a squared minus b squared. So because we're kind of swapping all the adding and subtracting, I hope it makes sense that now this one is going to be a squared plus b squared, okay? So for hyperbolas, we use this equation. If it was an ellipse, you would have a minus in there. So it's kind of just like swapping the plus for a minus in every case. And just as a reminder, obviously you can use equations for checks and things like that. So don't freak out about all of that. But that's kind of the big idea here for our hyperbolas. That's the basic of the equations here. And now I'm going to stop the video just so you can revisit this one if you need to, and then I'll walk you through some examples.